So scientists are studying matter, specifically chemists are studying matter, and there's just so much out there, so much information that we have to categorize things and classify things. So first of all, we need to define what is matter. Matter is anything that occupies space and has mass. So this means most of the things that we encounter are matter. So the bench top is matter. My keys are matter. What about the air in this room? That's matter. It occupies space. I mean, you can put air into a balloon and it'll fill up the balloon, right? It's not as obvious that air has mass, but it does. A specific type of matter is called a substance. So I'll be using that word a lot, a substance. So we take all these different kinds of matter and we classify them into different categories. And just like you could classify cars based on their type of fuel, or how many wheels they have, or how many doors, or what color, there's lots of different ways you could classify cars, right? We can also classify matter in different ways. So one way is to look at its physical state, its form. Is it a solid, a liquid, or a gas? Or we can look at the composition. What composes that matter? Is it multiple different types of substances mixed together? Is it all the same, etc.? So those are two broad categorization schemes. Looking at states of matter, the three states of matter that we will be talking about are solid, liquid, and gas. And those different states have distinct properties. I'm not sure what this green stuff is supposed to represent. But here would be the solid, a liquid, and a gas. And water is something that we experience in all three states. As a solid, we call water ice. The liquid we call water. And in the gas state, we call it mist or steam or vapor or humidity. There's water vapor in the air right now. As you heat a substance, it will usually go through transitions from solid to liquid to gas. In a solid, the molecules or atoms are packed together very closely. Matter is always in motion. The atoms and molecules are moving, but in a solid, they're not moving relative to each other. So I like to think of the three states of students, and right now, you students are in the solid state. You're moving, right? At the very least, everybody's breathing. Pretty sure of that, right? So you're moving, but you're not moving relative to each other. The person who's sitting behind you was sitting behind you 5 minutes ago. So you're stationary relative to each other, but individually you're moving. That's what's happening with the particles in a solid. So a solid has a fixed volume and a fixed shape because the particles don't move relative to each other. We can look at different types of solid matter based on how the particles are arranged. Solids can be crystalline or amorphous. Crystalline solids have an order to them, a long-range repeating order. So this part of the classroom here in the middle, you guys are crystalline because you're sitting in rows. And over there on the edges, that's more of an amorphous state of students because you're kind of disordered, hanging out on the edges because you're waiting for a seat. So amorphous solids, A is the prefix meaning without, morph refers to shape, so without shape, without long-range order. A diamond is an example of a crystalline solid. The atoms of carbon are all arranged in a very regular pattern. Things like glass, plastic, rubber, those substances are considered amorphous. There's not an order to their atoms. In the liquid, the atoms or molecules are still touchingly close, but now they can move relative to each other. So for students, when we have lab and do experiments, that's the liquid state of students. We're still in this room, we're confined to a fixed volume, but now you move around and you'll be going over to the balances and over to the hood and you'll be milling about. And that's what a liquid does. The particles move relative to each other as well as vibrating. So examples are water, alcohol, gasoline. Liquids have fixed volumes, but not fixed shapes. And you know that from just messing around with water as a child. You take water and you pour it into another container. It takes on the shape of the container, but the volume stays the same. In a gas, the particles are much farther apart. There's a lot of space between them. And because of this, gases are compressible. Solid and liquids have very little compressibility. So here we have a solid in a piston assembly here. The particles are already touchingly close. You can't push them together anymore. In a gas, there's a lot of empty space, and so if you put pressure on it, you can squeeze the particles together. You can change the volume of a gas. The gas molecules are moving relative to each other like a liquid does, and so the shape is also variable. So the gas state of students is when class is over and you guys effuse out the door and you scatter and you go off on your own ways, and you may not interact with each other again until you come back into the classroom. So any questions about states of matter? Classifying according to composition, the broad categories here would be elements, compounds, and mixtures. And this flow chart in your textbook gives an overview of this. So the first division is between a pure substance and a mixture. A pure substance, pure substance has only one component. The composition is always the same. So if you look at the individual particles in a pure substance, they could be atoms, they could be molecules, but they're all the same as each other. In a mixture, you've got two or more components. So you've got two or more different kinds of particles, and the composition could vary. You could have a little bit of particle A and a lot of particle B, or you could have even numbers. The composition can vary. We can take those pure substances and divide those into elements and compounds. And this is looking at, can those individual particles be broken down or decomposed into simpler things? If the components are a molecule, then it's a compound. We can take that molecule and take it apart into individual atoms. An element is already in its simplest form and cannot be broken down into anything simpler. Okay. So an element is composed of atoms. Those are the basic building blocks of matter. So an example would be helium gas. In helium gas, there's only one kind of particle. It's a helium atom. Helium atoms cannot be broken down into smaller, simpler things. In a compound, you've got two or more elements in a fixed, definite proportion. So water, we saw a picture of a water molecule earlier. One oxygen atom, two hydrogen atoms. So those are bonded together to make a water molecule. In the substance water, all the particles are the same. It's a pure substance. But you can take those molecules and break them down into oxygen and hydrogen. And so it is a compound, not an element. So those are the pure substances. Mixtures fall into two categories, homogeneous and heterogeneous. And in science, we use a lot of prefixes and suffixes, and so understanding what those mean can help you figure some things out. Hetero and homo. Hetero means different, and homo means the same. So heterogeneous mixture has different components. It's not uniform. A homogeneous mixture is very uniform. So the categorization is based on how uniformly those substances are mixed. A heterogeneous mixture, the composition varies from one region to another. So all mixtures are made of at least two substances, But in a heterogeneous mixture, they are separate, at least somewhat. So examples, a salt and sand mixture. So imagine taking a handful of sand and a teaspoon of salt and mixing it together in a bowl. You look at it and you can see the salt crystals and the sand grains, right? They are distinct from each other. That's a heterogeneous mixture. Another example would be like oil and water. So you mix oil and water together and they don't stay mixed very well. The oil rises to the top and the water stays at the bottom. And so if you took a portion of that mixture from the top or from the bottom, the composition of it would be different. The salt and sand mixture, if you took a very small piece of it, the composition is going to be different. And so that's characteristic of a heterogeneous mixture. Homogeneous mixture appears to be a single substance. It's the same throughout. And if you take a sample from different areas, the composition is always going to be the same because it's so thoroughly mixed. So an example of this given in your textbook is sweetened tea. In the South, they call it sweet tea. So you put sugar into tea and you stir it, and the sugar dissolves in the hot tea, and it's uniformly mixed. And if you were to taste from the top or from the bottom or from the middle, it would be equally sweet all the way through, right? Homogeneous mixtures have uniform compositions because the particles or molecules, atoms, mix uniformly. So mixtures can be separated into the individual components. And some mixtures are easier to separate than others. And this is a whole area of chemistry, separation science, where you're trying to separate things from each other. There are many different techniques. We're just going to talk about a couple of them. If you had a mixture of sand and water, put sand and water and stir it all up and then just let it sit there, the sand is going to fall to the bottom and the water's going to stay on the top. What kind of a mixture is that? Homogeneous or heterogeneous? It's a heterogeneous mixture. Heterogeneous mixtures are often easier to separate. We can separate the sand and the water by just carefully pouring the water off the top. You can imagine doing that, right? That's called decanting. Got to make it sound fancy and scientific, right? And decanting is a technique we will be using in lab, just pouring the liquid off. If you have a homogeneous mixture of liquids, such as alcohol and water, they mix thoroughly, and so you can't just pour the top off. If you had oil and water, a heterogeneous mixture, you could pour the oil off or skim it off. But alcohol and water mix thoroughly, and so you can't just pour off a different layer. So a technique used to separate those sorts of things would be distillation. Here we're making use of differences in the properties of boiling point. So water and alcohol boil at different temperatures. So in this apparatus, we have our mixture here, and we heat it, and as it warms up, the substance with the lower boiling point begins to boil. It goes into the gas state. And instead of just letting those alcohol vapors escape, we're going to trap them, cool them down in a condenser, and have them run into this other vessel over here, and we can collect the alcohol. What remains over here is the mixture, but now the mixture has less alcohol in it, and as you continue to distill this, you can get pretty much all of the alcohol out of the water, and then you're left with pure water over here and pure alcohol over here. Filtration is another method to separate mixtures. This is used when you have a solid and a liquid in a mixture. So again, this is a heterogeneous mixture. This is a technique that you use in the kitchen all the time. If you make coffee, if you boil spaghetti, you're going to do a filtration. So here we have our mixture of a solid and a liquid. Think coffee grounds in hot water. And we're going to pour it into this funnel with a piece of filter paper, the coffee filter. And the paper will catch the solid and allow the liquid to go through. So down here, you have the liquid, the coffee, without any of the nasty grounds in it. That's the basic principle of a coffee maker.